Okay, so we have a matrix here. We'd like to find the eigenvalues, and eventually we'll find the eigenvectors of this matrix. So what we showed in the last slide, was that the eigenvalues are solutions to the determinant of a minus lambda I equals 0 when our characteristic polynomial is equal to 0. So what we're going to do is we're going to calculate a minus lambda I. Then we're going to calculate the determinant, and then we will find its roots. Okay, so let's go. So first, a minus lambda I, we have a minus lambda times the identity. So this is going to just have lambdas along the diagonal and zeros everywhere else. So when I do a minus lambda I will just be subtracting lambda from everything on the diagonal. All right, so I've got a and everything on the diagonal lost lambda. Next, we're going to calculate the determinant of this. So p of lambda, this guy has a definite best choice. We're going to expand in this first column because we have all those zeros, and we start with a plus. So this determinant is equal to 3 minus lambda times the determinant of 3 minus lambda, 6, 1, 2 minus lambda. Remember that to find the little matrix that we're taking the determinant of, we need to cross out with the row and the column containing 3 minus lambda. And so we record just everything that's left. Okay, and here I've made a mistake that I see all the time. And I want to point out how difficult it is to read if we don't use parentheses here. If we have 3 minus lambda times this determinant, it's really hard to interpret what this means. So we are going to put parentheses around this so we know that we're multiplying 3 minus lambda by this whole determinant. Okay, and now we are ready to calculate 3 minus lambda times 3 minus lambda times 2 minus lambda minus 6. And because we're going to be looking for the zeros, we probably want to simplify this second term. So I'm going to multiply out and then try to refactor it. So we have 3 minus lambda times 6 minus 5 lambda plus lambda squared minus 6. Okay, notice these lambdas cancel, or these 6's, 6 and minus 6 cancel out. And so this factors as 3 minus lambda times lambda times lambda minus 5. Okay. And our final step in finding our eigenvalues is just looking to see where p of lambda is equal to 0. So p of lambda is equal to 0 if 3 minus lambda equals 0, when lambda equals 0, and when lambda minus 5 equals 0. So my eigenvalues are 3, 0, and 5. Next, we're going to see how to calculate our eigenvectors when we know our eigenvalues. Okay, so we're going to do another example. We want to find the eigenvalues of this matrix C. We know that finding the eigenvalues is the same as finding all solutions to the characteristic equation being 0. And we find the characteristic equation by calculating the determinant of our matrix minus lambda I. So we're going to start by writing down C minus lambda I. Okay. So this is 1, -2, -2, 1, and I'm subtracting lambda times the identity matrix. So lambda 0, 0, lambda gives me the matrix 1 minus lambda, -2, -2, 1 minus lambda. Next, we calculate the determinant. Okay, so the determinant of this thing is going to be 1 minus lambda times 1 minus lambda minus -2 times -2, so minus 4. I'm going to simplify this, combine these terms. I get lambda squared minus 2 lambda plus 1 minus 4. And I can simplify this further. I get lambda squared minus 2 lambda, minus 3. And now I can factor as lambda minus 3 times lambda plus 1. Okay, so my eigenvalues are going to be the solutions to P of lambda equals 0. So I end up with two distinct eigenvalues. I have lambda equals 3 is 1, and lambda equals -1 is another eigenvalue. Okay, now for real, we're looking at how to find eigenvectors next.